today we will be uh, talking about the very nice powerful feature that's offered in our mill module, which is called the knowledge bases, and we'll try to go over these features in our flagship standalone product, which is Visual CAD/CAM. We'll also talk about this in RhinoCam and in Visual CAM for SolidWorks. Now, for those of you who are not familiar with what knowledge bases are, now the mill module includes a very powerful feature called knowledge base, which basically makes push button programming a reality. So what this allows you to do is, once you have machining operations that you may have programmed in your current file, once you have it programmed, these machining operations, what you currently have programmed, can be archived and saved into a knowledge base, which allows you to basically take these operations and apply those operations on other files, or maybe like a family of parts that you may be working on, so you can basically take advantage of reutilizing these operations. Now, saving operations to a knowledge base will basically save or archive the entire strategy of operations. You could have one or many operations saved to a knowledge base. So basically all the operations that you have programmed under the machining job will be automatically saved into a knowledge base once you save it. Now, when you save the operations to a knowledge base, it will be able to save the information about your tool, your feeds and speeds, your clearance, your parameters that are specified in each of these operation types. So these parameters are saved. What's not saved by default to a knowledge base is your control geometry and the generated toolpath, because the control geometry would vary from each part to part. So what gets saved to the knowledge base when you do a save is basically your entire workflow of machining operations, including the tool information, your feeds and speeds, your clearance information, your cutting parameters. Now, on this particular file that I currently have open here, you see that I have 4 different operations. I have a facing operation, I have 2 pocketing operations, and finally I do have a profiling operation in here. Now, saving this operation to a knowledge base will also save the information about your machine definition. If you have it defined as a 2, 3, for 2 and 3 axis, it's defined as 3 axis, and 4 and 5 axis, and also the host processor that's being utilized to program this file. So to save operations to a knowledge base, you would go over to the machining browser, and right in the program tab, you'll see a group called knowledge bases. When you click on knowledge bases, you'll find 2 options. Load KB. KB is basically an abbreviated form for knowledge base, and we have save to KB. So before we can load a knowledge base, we first have to create and save operations to a knowledge base. So I'm going to use this option called Save to KB, which allows you to save operations to a knowledge base. So when you click on Save to KB, this allows you to select a folder where you'd like to save it in. So I'm just going to go and point to a folder, and I'm going to call this 2-axis methods, or you can name it whatever you'd like to, and I'm going to just append 2016 to the end of it, and you'll notice that the save as type is automatically set to .vkb. These are the file type extensions that are used for knowledge base files. So once you hit save, the entire workflow of these operations are saved to a knowledge base. Now, the same features are also available in our plugin for Rhino and RhinoCam. So you could go over to knowledge bases and then pick save to knowledge base and save them into a knowledge base. Now, you could also do the same thing inside of your SolidWorks plugin, which is Visual CAM for SolidWorks. Go over to knowledge bases, and then you can pick save to a knowledge base to save the operations to a knowledge base. Okay, great. So now what we have done is we've actually saved the operations into a knowledge base. Now let's go ahead and load this knowledge base on another part we would like to program in here. So I'm going to go up to the File menu, and we'll try to open up another part in here. And there it is. So I have another part which has similar types of features where I would like to do some facing, pocketing, and profiling operations. So to load these operations from the previously programmed part, since we have them saved to a knowledge base, we would go over to this group called knowledge bases under the program tab in machining operations, and then we'll go select load knowledge base. Now I'm going to go point to the folder where I had it saved. I had it saved as 2-axis methods 2016. So I'm going to select this knowledge base and then click open to load it. You will now notice that the operations that were programmed, we had a total of 4 operations. We had a facing operation, we have 2 pocket operations, and we also have a profiling operation in here. Now if rules have been assigned to the knowledge bases, you will notice that these operations would automatically have the geometries that are automatically pre-selected to us. So in this particular case, you notice that when I brought in the knowledge base, these automatically had some rules assigned to them, and so it automatically loaded those knowledge bases with those rules. Now we will talk about during the course of this webinar how to create these rules and generate toolpaths for it. Now let's say, for example, I wanted to bring in a knowledge base without any rules in here, so I'm going to go back to this knowledge bases tab and click on load knowledge base, and I'm going to bring in one of my knowledge bases which does not contain any rules. So now you notice that when you bring in a knowledge base or a saved knowledge base, you'll be prompted with this dialog which says there are no selection rules assigned to it. Would you like to set them? Now in this particular step, I'm going to select no and not have any rules assigned to it. So you will now notice that there's basically the same set of 4 operations, a facing and 2 pocketing operations and a profile operations. So in a typical scenario, you would basically go through each of these operations, you would edit the operation, and then go select the geometry that you'd like to use as your part geometry or the drive geometry to program these toolpaths. If it's a 3-axis toolpath, you would be selecting what is called a containment geometry. So in here, for the part regions, I could go select the curve geometry in here. So I would like to face this entire part. So I'm going to pick this rectangular geometry, the curve or the sketch on the part. Right-click to press enter to accept your selections, and then you can verify that the tool that's being used is already loaded from the knowledge base. Your feeds and speeds are also being loaded from the knowledge base, and so is the clearance and your cutting parameters, your parameters for roughing, your cut levels. All of this information is being loaded from your knowledge base, and then when you hit generate, you'll notice that the toolpath is automatically created. So it saves you time in going to have to enter or input these parameters, when you program family of parts or parts that are similar to it. Now we would have to go through the same process in here to basically add geometries to it. So I'm going to edit this operation, click on select curve edge regions in here, and I can select the features for pocketing. I can either select the floor of the part, like a flat area at the floor of the pocket, or I can even pick a curve or a sketch on this geometry in here, and I'm going to select all of these as the geometries for my pocket operation, and then pick generate. So after loading a knowledge base, what I chose here was just the machining features of the drive geometry. Now since the depth parameters were exactly the same as what we had set in the previous part, I did not have to go back and change any of my depth parameters. But if I need to change the depth, if the part has a different depth, you can always go back and edit the operation and specify the depth under the cut levels tab in here. Now I would like to go back and pocket this through hole in here, so I'm going to edit the pocketing operation number 3, select my drive geometry. I'm going to pick the curve, or I could pick the surface edge, and then generate it. Now finally, I would like to go profile around the periphery of the part, so I'm going to double click on this to edit the operation, click the select curve edge regions, and select the feature from the edge of the part, right click on it, and then I pick generate. Now you'll notice that within a few minutes I was able to program an entire part, or like a family of parts, a class of parts, by loading machining operations from a knowledge base, as opposed to having to recreate them by selecting each of these operations individually from the methods under 2 or 3 axis. Now creating a knowledge base And saving knowledge bases will save you significant programming time when you have parts that are similar or you would like to use a similar type of workflow. Now, in a family of parts situation where the machining operations can be applied to these parts, it would be more appropriate to archive these processes into a knowledge base. So that way you can reutilize the same knowledge bases on the files, and also with these knowledge bases set, you kind of developed a very good workflow that works best for your applications, and you can keep loading these knowledge bases back into the part. Now, let's consider an example in here where you may not want to have all of these operations loaded, but you may only want to use a couple of these operations. Now, one of the ways to select what operations to use from a knowledge base is by using this tab called K-Bases that's found in the Machining Objects browser. So if you click over to Tools and Machining Objects, you will see that there's 4 tabs in your Machining Objects browser. The Machining Objects browser may appear over on the right side, to the side, or may appear right below, depending on how you have the browsers docked in your application window. Now, you could either have it docked below or you could have it docked over to the side. Now, folks, for those of you who are using our Visual CAM plugin inside of SolidWorks, your Machining Objects browser would typically appear right below the Machining Operations browser right here. Now, for those of you who are using either our plugins for Rhino, which is RhinoCam, you could either have it docked over on the side or you could have it docked right below the Machining browser. Now, I'm going to go ahead and load the same part we programmed in the standalone system, which is Visual CAD CAM. So I'm going to bring in this part, and I'll dock this browser window right below the machining operations. Now, this particular part currently does not have any machining operations as you see it. And let's say, for example, on this part, we would only like to program the pocket and the profile operation and exclude the facing operation. So rather than loading the entire knowledge base by going up to the load knowledge base and applying all of the machining operations, one of the ways you could do it is you can go up to the Machining Objects browser and go over to the tab called K-Bases, which basically is an abbreviated form for knowledge bases. And here you have an option to load your knowledge base. You can click on Load Knowledge Base, and again, I'm going to go locate the same knowledge base that we loaded in our standalone product, and you're prompted with this dialog which tells you that there are no rules assigned to any of the operations that are in your knowledge base, and would you like to set them. Now, we'll talk about how we can automate selection of control geometry in the next few steps, but for now I'm going to click on Do Not Assign Any Rules, since I would like to manually select geometries for machining. Now here you'll see that there's a total of 4 operations. Now if you'd only like to use the pocket and the profile operation from this knowledge base, you can select an operation and drag and drop it into your machining operations browser. So you can just hold down the left mouse button and drag it over to your machining operations browser, and then let go of your left mouse button. So this automatically drags this operation from the Machining Objects browser into the Machining Operations browser. Now I could repeat the same step in here for the 2-axis profiling, holding down the left mouse button, drag it, and then once you drag it into the Machining Operations browser, you can let go of the left mouse button, so that it'll basically move or copy the machining operation from your knowledge bases tab into the Machining Operations browser. I'm going to go ahead and temporarily close the Machining Objects browser. So now you'll notice that you are able to just selectively pick or choose the operations that you'd like to use for programming it in here. So now I can go back in here and edit the operation. So I can do a double click to edit the operation and then select the control geometry I would like to use for programming these operations. So you could either be selecting surface edges, or you could select curves from your 3D geometry as your drive containment region to program the toolpath, and then click Generate. So you have options either to load the entire knowledge base and program it, or you could selectively drag and drop operations from your knowledge bases using the K-Bases tab and drag them into your machining browser to program it. Now, folks, if you do have any questions during this webinar, feel free to post them in the questions panel, and we'll try to answer them as quickly as you can. If you'd like me to go over any of these steps that we just went through during this webinar, please feel free to let us know if there's anything that's not clear to you. We'll try to make it as easy as possible to explain them over to you again. So what we discussed right now is how to save or create a knowledge base, and then how to load a knowledge base. And upon loading a knowledge base, we talked about how to select control geometry and generate the toolpath. Now, in the case of two-axis operation, you would have to select your control geometry. In cases of three-axis operations, you could select control geometry, or you could not have it select any control geometry in the case of roughing or parallel finishing or horizontal finishing operations. Now, some of the three-axis operations which require like a drive or part region, you would have to edit and select the control geometry on it. Now, the workflow would also be very similar inside of SolidWorks as well. So you would basically save the operations to a knowledge base. Once you have it saved, you can go ahead and pull in another part in SolidWorks in here. So I'm going to go back and load another part. And if you like to load your knowledge base of machining operations, you just go over to the K-Bases tab to load a knowledge base, and you can selectively choose what operations you would like to use. So you can basically load the knowledge base and then pick the knowledge base file that you like to load. And if there aren't any rules set to the knowledge base, you'll be automatically prompted with this dialog prompting you to set rules to it. And for now, we'll click no to set rules to it. Now, for example, on this particular part, we would like to program just a facing and a pocket operation. So I'm going to select the facing operation and drag it from the machining objects browser and drop it into the machining operations browser. And I'll repeat the same step for the pocket operation, drag it and drop it. Now for the facing operation, I'm going to double click to edit the operation and select the feature. So I can use select curve edge regions. And in SolidWorks, you can right click on an edge and use select tangents here or select loop to basically go select the chain of edges in here. So I'm going to use the select loop option to basically select the entire chain of edges, then accept the selection. And if I need to make any changes to the parameters in here, I can specify those and then hit generate. And there's my facing toolpath. And I'm also going to program the pocket toolpath in here. Select my drive geometry. And in the cut levels, I'm going to specify the geometry I chose is at the top. And I can pick the depths by selecting the top face and then the floor of the pocket and generate the toolpaths in here. So now I got to specify my cutting parameters. I can set the cut depth, all the parameters, and generate the toolpaths in here. So this is how you can basically effectively load your knowledge base and select machining geometries to program your toolpaths in here. Now let's go one step further and see how we can automate these knowledge bases in Visual CAD/CAM, in RhinoCam, and also in Visual CAM for SolidWorks. Now for this, first I would like to start by illustrating using a 2D example, like bring in a geometry which has some curves or sketch geometries, and then we'll extend this to also a solid surface geometry for applying rules, selection rules for knowledge bases. Okay, so I'm going to go ahead and load this part in here. So what I have here is basically a pretty simple part which has a bunch of features that I would like to program in here. So now I have these operations. I would like to program several operations. Now if you take a look at the layers or the layer managers, you'll notice that I have several layers on this file and have grouped the objects into different layers. So for example, I have all of the holes that are up to a certain size grouped into a layer called holes small. I have holes of the larger sizes grouped into a layer called holes large, and then these pockets, the rectangular pockets that you see in here, I have placed them on a layer called pockets, and all of these points in here I have them on layer called drill points, and the text that I would like to scribe or engrave are on a layer called engraving, and finally the outside periphery of the part, I have it on a layer called cutouts. Now let's go ahead and program this part. Now I have the same setup also in Rhino as well for those of you who are using or familiar with RhinoCam. So I'm going to go ahead and load this part in here as well. You'll notice that we have the same part and we have the same setup for layers. Now folks, for those of you who are using our plugin in SolidWorks, SolidWorks does not offer or have an option similar to Rhino or Visual CAD where you can have layers to manage geometries, and we'll talk about how we can assign rules and program parts inside of SolidWorks as well. So first we would like to turn our attention towards our standalone Visual CAD cam and also the Rhino cam, and then we'll also demonstrate this inside of SolidWorks how we can effectively assign rules and program it. So in here what I have is basically this particular part has operations program. So we have engraving operations program for these points and also for these the text that needs to be engraved. We have a hole profiling operation that's programmed for the holes of a certain size. There are smaller size holes, and we have a profile operation program for these larger holes in here. And then finally we have a profiling operation that's programmed for the outside holes in here, for the outside cutouts, I'm sorry. So now let's go ahead and apply the same set of operations to another part. So if I go in to another part, I'm going to load a part called part number 102 here. You will notice that this part has several of these features, and if you load a knowledge base, and you basically have to go through the process of selecting each of those machining regions individually. So if you load in a bunch of operations in here, so for engraving, I would have to go and manually pick what features to engrave. So I could select curves as region, and I would have to go through the process of either selecting them from a layer, or I would have to go through the process of selecting them individually manually. So if I click on select curve edge regions, I would have to go and manually select the geometries from each of these parts to program them, or I could right click on the layer called engraving and use select objects. Now this can be done in Rhino. Rhino allows you to select by layer, so as Visual CAD, but still we got to manually go through the process of selecting each of these geometries in here, so for programming it, so when no rules are being defined or assigned to a knowledge base. Now in the next step I'll show you how we can automate the selection of these control geometry, which will basically make your programming a lot faster, a lot easier, and save you time in having to go through the process of selecting these geometries. Again, in 2-axis profiling, I'm going to use select curve regions, and I'm going to use the geometries that are on layer called holes large, right click and use select objects and generate it. Now this is how we were used to be doing in the older versions of our CAM product, where we had to select geometries once you load a knowledge base. Now with the 2016 version, we can assign rules to it, and we can automatically automate the selection of geometries. So what I'm showing right now is how we were able to do it in 2015 and older versions, and also how we can still continue doing it in 2016. But you would want to save the time that you put in for selection of these geometries. So in order to do that, we would need to establish some rules for each of these operations in here. So in order to establish those rules, what I'm going to do here is go over to the machining objects browser, and then right from this K-Bases tab, I'm going to use this option called load knowledge base, and I'm going to load the same knowledge base, which is called part number 101. And you'll now notice that it prompts us saying that there are no selection rules. Would you like to set them? Now in this particular case, since I would like to set different rules for each operation, I do not want to assign the same rules for all operations. I'm going to select no, and you'll notice that the operations are still loaded. Now for the time being, I'm going to go ahead and delete these operations that we had programmed in the machining operations browser. Now as you take a look at each of these operations and you expand the operation folder, you will see that there's an entry called selection rules. So you can now assign rules to it. So you can double click on this and you can now specify what type of geometries would you like to select or have it assigned automatically. So you can either use geometry type filters. And if you're using arcs and circles, you can specify the range for the diameter for the arcs and circles. If you're using rectangles, you can specify the minimum side length to be selected for rectangles, and you can also apply geometry property filters. Now, we can also use layer options in here. If you have the objects set or grouped into layers, you can also use the layers. Now, for example, for the engraving operations, if you already have the part prepped up and you have them placed into layers as you like them here, you can basically say for engraving operations you would like to use all objects that are on layer called engrave and pick OK. So you'll now notice that the flag that was on the selection rules folder is cleared once the selection rule is set. Now you can go back and edit the selection rules to take a look at what you have set, and you can see that it has the layer engrave selected, so automatically it'll apply the layer called engrave when you load the knowledge base again. Now in the next step, I'm going to go to the hole profiling operation, and in here I can either use a layer filter and select the layer called holes small, or I could specify to have it select arcs and circles, and I can specify a range for it. I could say pick all the circles that are of range up to a maximum diameter of 1 inch. I'm going to do the same thing for the profile inside, where I'm going to use arcs and circles and set a diameter range from 1 inch all the way up to 5 inches. Next, for the last operation in here, I'm going to edit the selection rules, and I'm going to use a layer filter and say pick all geometries on layer called cutouts. And I'm going to pick OK in here. Now you can see that all of these rules have been, selection rules have been set for these operations. Now I'm going to save this to a knowledge base again, and I'm going to specify the folder where I'm going to be saving it. I'm going to call this part number 102. I'll call it with rules. Now as you go over to your machining operations browser, you can load the knowledge base, the one with the rules on it, and now you will notice that automatically the geometries have been assigned to it based on the rules that you put in. So you'll notice that the engraving operation automatically selects all of the geometries on layer engrave. The hole profiling automatically selects all of the holes that are up to a 1 inch in diameter size. The larger holes are being automatically added to the profiling inside operation, and then the cutouts have automatically been added to the profiling outside. Now with this workflow, by assigning rules to your selection rules to your operations in the knowledge base, you're saving time in having to go through the process of selecting these geometries for machining. So now I'm going to basically select the setup, right click, and regenerate. So you'll now notice that the operations have automatically been computed and processed for this particular part. Now let's go ahead and take a look at another part in here. So I'm going to go up to open, and I'm going to bring in another file in here. I'm going to use this part called part number 103, and all I'm going to do is load my knowledge base. You'll notice that I already have the geometries in this part automatically mapped to the same layer. So you can basically map them into layers. So you can either select them either based on layers, or you can select them based on geometry types. So we'll click on load knowledge base again, and I'm going to load the same knowledge base, which is called part 102 with rules, and then select open, and all I got to do is right click and regenerate, and you'll see that all of your toolpaths have been generated, so it automatically has the machining geometries or the control geometries selected. Now this workflow also works the same way in our standalone system, Visual CAD/CAM. So I can set my knowledge base rules by going up to the K-Bases tab, load a knowledge base, and define the rules. Now since I already set those knowledge base rules in here, I'm going to load the knowledge base, and you'll now notice that it automatically has all of the geometries automatically selected based on the rules that were set into the knowledge base. So here's an example of how you can program it effectively on geometries that require 2-axis machining, since these rules are being set to geometries like curved geometries or sketch geometries that are in your file. So you can click on load knowledge base, and then pick the knowledge base where you have the rules set, and you'll now notice that it automatically pre-selects the geometries for your machining process. So this is a very powerful feature, makes your workflow a lot more easier, makes it more productive, so you can actually have, several parts programmed in a very short span of time. Now let's take an extension of one other example in here before I turn my attention to a solid model. So I'm going to go over to the part in here where I have several different operations programmed on it. So we'll show you an example where how we can globally apply a set of rules to all the operations. Now in this particular part, I have facing operation, and I have a bunch of drilling operations, a drill, spot drill, drill, and a tap operation. Now when you do whole machining operations, like you may want to do a center drill, drill, and a tap, you're going to be reutilizing the same set of whole features for machining. So for example, I'm going to bring in another part which basically has not been programmed, but let's say I was only interested in programming the holes on these parts. So if I go ahead and load a knowledge base in here, and let's say I want to load this knowledge base into it, you can see that it says there are no rules set to it. Now this particular operation has three operations. You have a standard drill, like a spot drill operation, then you have a drill operation and a tap. Now for each of these operations, you would have to manually go and select those geometries. So I could say I want to select these holes in here, so I got to either manually select them from the viewport, or I can go and select each of these geometries by going over to the layer manager and then right click on the layer and picking select object. Since I need to drill and tap the same set of features, you could automate this by also saving to a knowledge base and assigning selection rules for it. Now you can notice that we had to go through this selection process 3 times for each of these operations. Now rather than having to do this in here, one of the ways you could do it is you can go up to your machining objects browser, go over to the K-Bases tab, and then you can load the knowledge base that has just the holes on it. So here I have a knowledge base which has the drill and the tap operations. And now, since I would like to assign the same rules for all the operations, I could choose in here, just click yes to set them, and then now I can say I would like to automatically select all of the holes for all the operations in this knowledge base. You'll now notice that it automatically has the rules set for each of these operations. Now if I drag this knowledge base over from the K-Bases tab into the Machining Objects browser, you will notice that each of these operations automatically has the region selected, and all I got to do is right click and regenerate. So by assigning rules, you can automate your selection process of geometries. So in this particular case, you wanted to do a spot drill, a drill, and a tap operation. So and since the geometries are going to be exactly the same for all 3, you can basically just assign one rule, and the rule can be applied to all the operations in that specific knowledge base. So this is also a very nice, powerful feature set which you can use, where you can assign the same rules for all operations, and this would be an ideal example where you would want to do that. So if I have a part that has several of these features in here, so I got a part where I need to cut several different parts in a sheet, and I would want to do the same whole machining operation, I could load my knowledge base which has the rules assigned to it, and automatically it'll basically apply the rules. So I can go back to the Machining Objects browser, click on Load My Knowledge Base with the rules, and I can assign it to automatically use all of the holes which are on layer holes, which is basically the points, and then basically drag and drop this operation over here, and you'll now notice that the operation automatically has all of the drill points selected. So all you got to do is, once you load it in, right click and regenerate, and there's your toolpath for it. Now the next thing I'm going to show here is how we can also apply rules and use these on some of the other 3-axis operations as well. So I'm going to go over to Visual CAD/CAM, and I'm going to bring in a part which has some 3-axis toolpaths in here. So I'm going to load this part, and you'll notice that this particular part has a roughing and a finishing operation in here. Now, I would like to utilize the roughing and finishing operation on the files. So if I go to my layer manager, you'll see that I have layer 1, which contains a curved geometry that's located in the floor of the part, and that curved geometry is used as a containment region just for the parallel finishing operation and not on the horizontal roughing operation. So for the roughing operation, I do not have any region selected. Now I'm going to go ahead and save this out to my knowledge base. I'm going to click on Save to Knowledge Base. I'm going to say 3-axis methods. I'll append 2016 to it, and I'm going to click Save. So I'm going to basically save this entire workflow of operations into a knowledge base. The next thing I'm going to do is load or bring in one of the other parts which I would like to program, where I would like to program the same set of roughing and finishing operations. Now once I have the part loaded in here, now for the roughing operation, I do not plan to use any drive containment regions, but for the finishing operations, I would like to have it contained into a specific area in here. So I would like to have it contained to this area. So I want to make sure that this particular curve can be mapped into the same layer. So you can see that I have it on layer number 1. If you go to Object Properties, it tells you that this particular sketch of the curve is on layer 1. Now I'm going to go ahead and switch over to the Machining Objects browser, and under the K-Bases tab, I'm going to click on Load My Knowledge Base. I'm going to go ahead and load this knowledge base in here, and it prompts me that there are no selection rules being set, and would you like to set them? Since I only want to set a rule for one of the operations and not all the operations in the knowledge base, I'm going to select no to it, and I'm going to go over to the parallel finishing operation and double click on it, and I'm going to say please select all geometries that are on layer 1. Accept it. Now I can save this to a knowledge base again. And the next step I'm going to do is load my knowledge base. And you'll notice that it automatically has the geometry selected. Since we did not apply a rule for the roughing, we wanted to rough based on the entire part in the stock geometry, but for the parallel finishing, we wanted to contain it to this area. So once you have it loaded, right-click and regenerate. So this is how we can apply knowledge bases with the rules for both 2 and 3-axis operations in here. So you can see the power of knowledge bases, and the ability to set selection rules makes it a lot easier to work with knowledge bases. Now let's take a look at a similar example inside of RhinoCam, and then I will turn my attention over to our VisualCam plugin for SOLIDWORKS as well. Now this is the part we looked at earlier during the webinar. So we have this part already programmed, and we have some rules assigned to it in here. Now I'm going to bring in another part, and rather than having to program and select each of the geometries, I'm going to load my knowledge base which already has the rules set to it, and I'm going to load the knowledge base with the rules on it. And you'll now notice that the facing operation automatically has it selected to select the rectangle which is on the layer called face. The pocketing operation automatically selects all of the pockets. The pocketing operation number 2 automatically selects the through hole, and then the profile operation automatically selects the profile from the part. Now you can set up these rules similar to how we did on just those 2D geometries by going over to your K-Bases tab. You can specify your knowledge base in here, and you'll notice that you can assign rules for each of these, and you can see that it's automatically selected to use the layer face for all facing operations. And similarly for the pocketing operations, it's automatically mapped to select the layer called pocket number 1, and you can see that for the pocketing operation number 2, the rules are being set to select geometries on a specific layer. So this is how we can assign rules and program the toolpaths. Now I'm going to turn the attention over to our users who use SOLIDWORKS, and here's how we typically set rules inside of SOLIDWORKS in here. So I'm going to go ahead and bring in an example. Now here we have a part where we have a bunch of holes that needs to be drill, and we can profile these holes. Now, the way we would basically save and load knowledge bases is very similar to how we noticed in standalone Visual CAD/CAM and in RhinoCam, but for the rules, it works slightly differently inside of SOLIDWORKS, because in SOLIDWORKS we do not use layers. There's no layer concept, so we would basically have to reference them using some sketch geometries. Now, the way we would do it is in SOLIDWORKS, you would have to have or create some extra sketches in here around each of these features that you're trying to select or automate the selection process. So if you take a look at the feature tree, I have a few sketches in here, and I'm going to select these sketches and make them visible. So I'm going to click on Show so that the sketches are visible. So you got to make sure that these sketches that are going to be used for selection rules are visible in SOLIDWORKS. So once you make those sketches visible, you can assign rules to it. So if you go over to the Features tab, the K-Basis tab, and you click on Load a Knowledge Base, I'm going to select the knowledge base to be loaded in here. So let me first save this to a knowledge base. Since I do not have a knowledge base for this, I'm going to click on Save to Knowledge Base. And from the K-Basis tab, I'm going to use Load Knowledge Base, and I'm going to go find the knowledge base where I have it saved in here. And now you'll notice that it prompts us saying that there are no rules being set, and would you like to set the same set of rules for all the operations? Since we would like to set rules independently, I'm going to click No to it. And now when I go to the standard rule operation in here, I can double click on my selection rules, and I can specify what geometries to pick. In this particular case, I'm going to use arcs and circles, and for the spot drill operation, I would like to spot drill these larger holes, the counterbores. So I'm going to specify a range for the diameter. So I'm going to say select everything that's between 0.7 and 0.8 inches. In the next step, I'm going to set the rules for the deep drill operation for these 3/8 inch holes. So I'm going to use select arcs and circles and specify a range. I'm going to use 0.3 to 0.4, so it automatically selects all of the 3/8 inch holes. And then finally, for the hole profiling operation, I would like to select my rules. So I'm going to set the rules to use the same larger holes, which are going to be the 3/4 inch holes. So I'm going to use 0.7 to 0.8 as the maximum diameter. Now once I have these rules set, I'm going to save them to my knowledge base in here again. And now, to program this part, rather than having to select each of these features manually, I could go over to knowledge bases, load my knowledge base, and select the knowledge base with the rules on it. Now you'll notice that it automatically has those geometry rules, control geometries assigned based on the rules that you specified. So when you right-click and regenerate, your toolpaths have been automatically computed, so we didn't have to go through the process of manually selecting each of those features. Now I'm going to apply the same to one of the other parts. Basically, I have 4 copies of the same part that's designed or modeled in SOLIDWORKS. And I'm going to go over that as well. So I'm going to go ahead and load this part in here, where you can see there's basically 4 sets of the same parts, and I have created sketches for each of these whole features on it. So if you look at the feature tree in SOLIDWORKS, I have these sketches. I'm going to basically make these sketches visible in here. And we'll load the same knowledge base that we used just a few minutes ago. I'm going to click on Load Knowledge Base and select the knowledge base to load, and you'll notice that the regions, machining geometries are automatically selected based on the rules that you put in, and now we can right-click and regenerate it. So this automatically computes the toolpaths for each of these operations. Now finally, the nice thing I'm going to show is how we can customize parameters for our machining operations, and we can save them to a knowledge base. Now for this, I'm going to start with our RhinoCam plugin, and then the workflow, the steps we do is very similar. So what I'm going to do is program a brand new part in here. So I'm going to go ahead and select the same part. And you'll notice that currently there aren't any operations. Now typically when you program a part, you would go up to the menu where you select the type of operations. Let's say you want to do a 2-axis and a pocket operation. And in this particular case, I'm going to select my features in here. So I'm going to select these pocket. Let's say I want to program this pocket. I select the pocket, right click, and then I go specify a tool for it, and then my feeds and speeds, clearance parameters, I can set it to be always use a stock max plus a half an inch for clearance. And in the cutting parameters, you would set all your parameters like your global tolerance, your stock allowance. You could say you want to leave only 15,000 stock. You can choose your cut pattern in here, your cut direction, your step over control. Now, every time you program a new operation by selecting from the 2-axis menu or 3-axis or any of the methods, you're going through the process of setting each of these parameters in here. Now, once you have set these parameters, you can customize them to be as your default settings. So I have these parameters set. I'm going to click on Generate. Now, the next time I program the same pocket operation, I don't want to go through the process of re-entering the same parameters again, and we have a very nice way of setting those defaults. So for example, if I'd like to use the same parameters on all the other parts I would like to program, you could save this to a default setting. So the default settings will save each of these cut parameters into a defaults file. In order to do that, you can select the operation, right click on it, and then go down on the menu here. You have an option that says Save as Defaults. So when you click Save as Defaults, this will prompt you to select this to a default knowledge base, and you can save them. You can based on like the type of material you're cutting, or you can create different defaults based on how you would like to name them. Here I could call it My Default Knowledge Base 1. So when I save this as a default knowledge base, you'll get a confirmation saying you've successfully saved it as a default. So the next time you go up to the menu and program the same operation like a pocket operation, you will notice that it automatically loads those parameter settings from the default. So remember, we had it set to 1,000 for the tolerance, stock to leave as 15,000. So you can see that all of the defaults are being loaded. So you can set defaults for each operation type. So if we can have a default for pocketing, profiling, each of these operation types. Now if you'd like to make a change to the default in here, you can go back and update it. So for example, you could say you only want to leave maybe 10,000 stock in here. So you can make the change. You can then go back and update your defaults file. You can do a Save as Defaults, and this defaults automatically gets updated. Now, if you take a look at the machining preferences, under the CAM preferences, you will notice that it loads the parameter settings from the defaults file. Now, if you want to go back to the system defaults, you can click on this menu and change it to undefined, and the next time you create a toolpath, if you program the pocketing toolpath, you'll notice that it loads it back from the system defaults file in here. So you can set up defaults and automatically have it load from the defaults file in here. So this will basically save you time in having to go back and re-enter the parameters every time you program a similar toolpath. So you can have defaults for multiple types of operations. So I can have a default for a profiling operation in here and have it updated to the same defaults file. So I can select my control geometry. So what's being saved in the default is just the parameters, the cutting parameters, your feeds and speeds, your clearance information, your cut conditions in here. You can choose climb cut. You can choose what site to cut is determined using 3D model automatically. You can specify any cut levels. You can also set your entry and exit parameters, any additional parameters. Once you generate it, you can save this to a defaults. Right click and use Save as Defaults, and you'll notice that it automatically updated the same default file for the profile operation as well. So the next time we call upon a profile operation, and not on this particular file, on any particular file that you're working on, it'll automatically load those settings from your default file. So you can notice that here it's automatically set to use 3D model to determine which side to place the cutter. You'll also notice that your cut direction is being loaded from the default file, which is basically set to mix. Now if you'd like to have more than one default being created depending on the type of materials you're working on, you could go back into the machining preferences and you can change this to undefined, so which will load it from the factory default settings, and you could go ahead and add a new default. So for example, I could select the same profile operation, I could make a change in here. I could say I want to set the cut direction to be conventional and generate the toolpath. And now I can save this as a default, and this will automatically prompt me to specify a name. So I can call this default knowledge base number 2 and hit save. So the next time you program a new profile operation, it'll use the parameters that you saved on the most recent default file, which is default knowledge base number 2, and you can see it's using the cut direction which was set to conventional. So this is how we can set defaults, parameter defaults, so it'll automatically load those settings, and this is how it works in RhinoCam, Visual CAD/CAM, and also inside of Visual CAM for SOLIDWORKS. You can select an operation in here, right-click, and choose Save as Defaults, and the settings will be saved into a default knowledge base. Now, folks, if you do have any questions, we'll be happy to take them. I would like to...
Uday, we do have a question. This question is, I'd like to know if there's a option to save or load an individual operation from a knowledge base, I assume.
Currently, when you save operations to a knowledge base, and if you have multiple machining operations, it basically saves the entire workflow of operations to a knowledge base. Now, if you'd like to save just an individual operation, one of the ways you could do it is you can go over to the K-Bases tab. You can load your entire knowledge base of operations in here, and then you can clear them out. You can delete those out in here from the tree, and then you can go back and resave that specific operation. So it'll basically have one operation rather than having to delete it from your machining operations browser. So currently when you save to a knowledge base, it'll save the entire set of operations and not just an individual operation. But if you want to just have one operation in your knowledge base, you got to go one extra step here. Go to your K-Bases tab. You can load the knowledge base, and then you can go back and save this out in here. I'm going to call this -1, so it only has one operation. So the next time I load this knowledge base in here, you'll see that it only contains one operation in that knowledge base. So that's the way how you can accomplish it in the 2016 version as of now.
Okay, Uday, we got another question here. I think it's more of a clarification. One user would like to know that when you use knowledge bases, that it only applies to operations. You still have to redefine your stock, alignment, work zero, etc. For each operation. I mean, for each part file. Is that correct?
The answer is yes. You would have to still define your, the part geometry, the stock geometry, but the knowledge base can also have information about your work zero. So if you have a work zero that's being set in here, for example, if I have a work zero added and if I have it set to a specific predefined location, when you load a knowledge base, it'll bring in the work zero at the same location. But if the stock extents are going to be different, you may have to go back and update the work zero as required.
Okay, here's another question. Can annotations be applied to the knowledge base to give them a detailed description?
Annotations in a sense you want to add some notes
you want to describe,
comments?
yeah, some comments or descriptions about the operation.
Okay. Comments can be added to each operation under properties. So if you go to a machining operation, if you go do a right click and go to properties, this is where you can specify comments, and these comments will be saved with the operation and can also be output in your G code if you have comments to output enable, or if you output a shop documentation, it'll output these comments.
So that's part of the knowledge base then?
Yeah, that basically gets saved with the operation and then goes into the knowledge base.
Okay. Here's another question. Can knowledge bases be used across platforms, such as if you had a bridge license between, say, Visual Cam and RhinoCam? Can you share the knowledge base?
Absolutely.
And what about for SolidWorks? Since it only doesn't support layers, is it still cross-compatible?
Well, with the selection rules, if you have it set to use geometries like arc circles or rectangles or curves, then it would definitely work. But if you have layers, since the layers are only applicable in Visual CAD and Rhinoceros, so the knowledge bases can be shared between Visual CAD, CAM, and Rhino CAM, but the knowledge base without layer information can be applied to Visual CAM and SolidWorks as well.
Okay. Here's another, I think this will be our wrap-up question. What happens when a new operation of the same type is saved to the knowledge base, but that operation may have a different description? Let's say it's a 2.5 axis pocketing operation, but it may have a different description, say, but it's still a pocketing operation. Does it overwrite the existing pocketing so you have one set of each type of operation in the knowledge base?
Are we talking, if you're talking about customizing default parameters, you can only have one of each operation type saved to the default. So if you had, in this case, I have 2 pocket operations. So if I save this to a default and then I go back and select the second operation and save it to a default, it'll update it to the most recent operation that you chose.
What about the knowledge base?
You can have multiple operations of the same type when you're saving it to a knowledge base.
So if you have a different name, like a different type of pocket, say by just different name by description, then they would both be saved.
Absolutely. I can call it Pocket 1 and Pocket 2.
Mm-hmm.
And this will basically be saved with the exact same names to the knowledge base. I just want to make sure that our users are not getting confused or with the way we save these to a knowledge bases to bring the entire workflow of operations versus the defaults. Defaults are only used to save parameters as a defaults file, so you can basically use those settings when you create a new operation by selecting them from the machining operations menu.